Hi class, welcome to lecture 3.3, which is really just me going over your test guide, in particular the 10 problems that are math based. Let's start with number 31. These 10 problems, by the way, will likely be on exam 3, so you should know how to do all of them. Now 31 is more of a conceptual problem than a math problem in some ways, but you still have to understand some basic ideas in math to be able to figure this one out. So let's look at it. Which one of the following statements is true? Now, whenever you get one of these questions, it's probably in your best interest to, try to negate the wrong ones as well, right? So, if you will look in the middle here, you'll see that I've given you kind of a cheat sheet for figuring this problem out. Usually at issue, yield to maturity is going to equal your current yield, which is going to equal your coupon rate. And the reason for this is because the price is equal to par, okay? So, this is what happens usually at issue. Then usually right after issue, if the interest rates go up or down, you're going to get a change. So remember, price goes in the opposite way of interest rates. So if interest rates go up, price is going to go down. It'll be below par and sold at a discount. If interest rates go down, price will go up. It'll be above par and sold at a premium. Now, since interest rates, and this is an important point, if interest rates is essentially the same thing as yield to maturity, something we've talked about quite a bit. You saw for the yield to maturity on a bond, you know what current market interest rates are. Then it's really easy to remember. So look at that second line. If interest rates go up, then you would expect the yield to maturity to be the highest, right? Because it's the interest rates. Then next is going to be current yield and then coupon rate. If interest rates go down, you expect it to be at the bottom and then current yield and then coupon rate. Notice that the current yield is always in the middle, and then you got yield to maturity and the coupon rate on the two extremes. So with knowing this information, you should be able to go up and answer this question. A, the current yield on a par value bond will exceed the bond's yield to maturity. Well, this is obviously false. We know that if a bond's priced at par, then current yield, yield to maturity, and coupon rate, they're all going to be equal. So that one's wrong. Let's look at B. The yield to maturity on a discount bond exceeds the bond's coupon rate. So you go down to that line where you have the discount bond, you see the yield to maturity is the highest. It's definitely going to exceed the coupon rate. So that one is true. So your answer is B. Now, if you're not real sure, you can go through C, D, and E and prove those wrong. The current yield on a premium bond is equal to the bond's coupon rate. Now we know that's not true because think about this. If we're selling a bond at a premium, then those three rates aren't going to be equal. Okay, so with a premium bond, the coupon yield is going to be less than the coupon rate. So let me say that again to make sure you heard me right. The answer there would be no, because the current yield is less than the coupon rate. Okay, that's going to be true for any bond sold at a premium. D, a premium bond has a current yield that exceeds the bond's coupon rate. Okay, now this one's wrong for the exact same reason C was wrong. Okay, so in this case, it's not saying that they're equal, but it's got the signs backwards, right? Remember that the current yield is going to be less than the coupon rate for a premium bond, so this would be wrong. And then finally E, a premium bond has a coupon rate that is less than the bond's yield to maturity. Okay, once again, this is going to be no for a very similar reason. Not only in the previous two answers was the current yield less than the coupon rate, but the yield to maturity is certainly going to be less than the coupon rate. So the only correct answer there is B. Now, I will on an exam probably ask you to solve this with 5 different answer choices, but they're all going to be based on that kind of cheat sheet information that I provided there for you. Now let's take a look at 32. Okay, a $1,000 face bond is currently quoted at 98, and then does that say colon too? Golly, what is that about? Well, now a colon, anything after a colon, is going to represent a fraction. And remember that from our lecture that bonds are priced as in terms of 32, like fraction over 1 over 32, so 30 seconds, right? And I'm not talking about the time, I'm talking about 1 over 32. So in this case you have 2 over 32. So this is going to be priced at 98 and 2 over 32% of par, because they like to price bonds as a percentage of par. Okay. I know that sounds a little bit strange, but bear with me. The bond pays semi-annual payments, most bonds will, of $29.50 each. So they don't have to give us the coupon rate here because they already told us what the actual semi-annual coupon would be. And it's going to mature in 14 years. So what is the coupon rate? Now, I solve here for coupon rate, but just to be fair, I want you to know that I could also ask you for the yield to maturity or the current yield. So I went ahead and solved for all three of them. So the first thing we're going to do here is the coupon rate. And as you can see, if you remember from the formulas, the coupon rate is used to figure out the coupon. So you can use that formula off the bond cheat sheet, rearrange it for and to figure out what the coupon should be here. So I've rearranged this to where the coupon rate equals 2 times the semi-annual coupon over par, which is $1,000. So 2 times $29.50 over $1,000 gives us 5.9%. All right. Now, what about the yield to maturity? Well, the yield to maturity you're just going to figure out using your time value money buttons. So for your N, you're going to plug in 14 years, right? No, that's wrong. Remember, you've got to make sure that you've got the right periods for your N and your I and your payment. Okay? Here we're dealing with a semi-annual bond, so it's going to be 14 times 2, so your N would be 28. Your I is your yield to maturity, okay, which is what we're going to be solving for. Your PV is going to be the price. Now, that's going to be 98 and 2 over 32% of par. What I usually do is figure out what it's 2 over 32 first, and then I add that to 98, okay, and then I multiply all of that by $1,000, right? So that's probably the best way about going at trying to figure out, what your price is. Now it's going to be negative when, remember, with bonds, the price is always negative when you put it in for PV. With the payment, they've already told you in the problem that it's $29.50, and then future value is always going to be par, which is $1,000. So solve for I, and you've got your yield to maturity, right? Well, not really. What you have is that semi-annual yield to maturity. Remember, you got to make sure your periods are right here. So you're going to end up solving and get 3.0539%. Multiply that by 2, and now you have your annual yield to maturity, which is closer to 6.1%. Okay? What about the current yield? Well, we haven't talked much about current yield, but the current yield, remember, is your annual coupon. Remember that word annual. It's your annual coupon divided by price. So what I mean by annual is you can't use $29.50. That's your semi-annual coupon. So you have to multiply that back by 2 to get back to your annual coupon. All right, and then you're going to divide that by the price, which you've already figured that out in step 2. So you solve there, and you're going to get 6.02%. So one interesting thing about the previous problem, number 31, is that you can check your math here a little bit by conceptually understanding what the relationship between these three rates should be for a discount bond. Now, since this bond's at a discount, you expect yield to maturity to be the highest, and it is at 6.1%. Current yield to be next, it is at 6%, and then the coupon rate to be next, and it is at 5.9%. So if they didn't go in that right order, that would be a good sign to you that you must have made a mistake. Now what about number 33? Number 33 is a zero coupon bond problem. It's actually got regular bonds in it too, but it introduces the idea of zero coupon bonds again from our lecture. So suppose your company needs to raise $38 million. Now why would it need to do that? It's raising money for some kind of a project or something like that, and it doesn't want to go to the bank. It wants to issue 20-year bonds for this purpose. Okay. Now notice everything here I'm circling in all these problems is a good indicator of something I might change on the exam. So on the exam I could say this company's raising $25 million and it wants to issue 10-year bonds, right? Whatever. Now assume the required return on your bond issue will be 7% and you're evaluating 2 issue alternatives. A regular bond, and that regular bond, notice it's got a 7% annual coupon. So if it's being issued at 7%, and you're going to require 7% because that's what current market interest rates are giving you. So those 7% are going to match up. One's your yield to maturity, the other's the coupon rate. And remember that a lot of times you're going to issue bonds at par anyway. This all is just lining up to tell you that the price of these bonds is going to be $1,000, right? Now, on your second alternative, that's a zero coupon bond, and we know that that's not going to be at $1,000. Zero coupon bonds don't pay any interest, so you expect to buy them at a very, very, very deep discount. Okay. Now, your company's tax rate is 35%. That's just filler information. It doesn't really matter for this problem. I could change that number, and it's not going to change your answers at all, right? And then in 20 years, why 20 years? Because that's how long the bonds are for. What will your company's repayment be if you issue the regular coupon bonds or if you issue the zeros? Now, zero is just a fancy nickname for zero coupon bonds. Assume is annual compounding on the zero coupon bond in this situation. It doesn't matter a whole lot how you do your annual compounding because you're not really got interest payments, but there are some weird reasons why it would matter, but we're going to just assume annual compounding here. Okay. Now, step one. Let's look at coupon bonds first. As we just talked, the price of a 7% annual coupon bond is par value because the yield to maturity equals the coupon rate, right? So now, how many bonds do I need? I got to raise $38 million. So if I'm selling them for $1,000, I'm just going to take $38 million and divide it by 1,000. I've got to sell 38,000 bonds, right? Now, what they're asking here is what will your company's repayment be if you issue these coupon bonds in year 20? Well, you've been paying interest along the way, but in that last year, you not only have an interest payment, but you also have to pay back the par, right? Par value, the principal. So you take the number of bonds that you've issued, which is 38,000, and then you're going to multiply them by one annual coupon, because it's an annual bond, plus par, which is going to be $1,000 plus $70, which is that annual coupon, right? So you multiply all that together, and you're going to write a big fat check in that year of $40,660,000. Okay. Now that little note there is just kind of maybe a quick trick that you could have also used to figure out your last payments, which is just to take the amount that you need and multiply it by 1.07. Okay, and that would give you the exact same answer as well. If that's kind of confusing, then just go back up to the 3 steps above. No big deal. Now, what about with zero coupon bonds? Okay, now with zero coupon bonds, there's a little bit more work involved, mainly because you got to find price. And usually, when you see a zero coupon math problem, the first thing you're going to do is figure out the price, because remember, they're sold at a deep discount, and you want to know what that deep discount is. So let's remember it's annual compounding, so we're going to make n equal to 20. I is going to be equal to 7% because that's what current market interest rates are. We're solving for PV because we want to know the price. There's no payment because why? It's a zero coupon bond, right? And then the future value is 1,000, which is what you'll get paid when these bonds mature. So you compute for price, and you're going to get $258.42. Okay, so I told you it's going to be sold at a deep discount. That's a real deep discount, right? Now, how many bonds would you need to raise this amount of money? You're going to have to sell 38 million divided by 258.42. You're going to have to sell about 147,048 bonds. Okay. Now, some people could argue here that you have to actually sell 147,049 bonds. It doesn't really matter. I'm not real worried about it to that specific degree, but just get close enough and you'll be okay here. So your last payment is going to be the number of bonds needed, okay, times the annual coupon plus par. Now, there is no annual coupon, so you're just dealing with par. So this is going to be $147,048, pretty much times 1,000. So you're really looking at $147,048,000. There's an extra $11 and some change, right? So what's the big point here? The big point is that last payment you make for a zero coupon bond is, if you issued zero coupon bonds, is going to be much, much bigger than the coupon bonds. And you're going to say, well, why would anybody issue zero coupon bonds then? Well, remember that you didn't have to pay interest on your zero coupon bonds. You weren't making any interest payments there to whoever bought these bonds. But with the coupon bonds, you were paying interest along the way. Okay, so it's kind of what would you rather do? Pay now or pay later? And so hopefully that helps you understand a little bit about how coupon bonds and zero coupon bonds may work. Now let's move on to 34. Now 34 is kind of a slight conceptual twist, and as long as you get that, this is a super easy problem. LKM Incorporated wants to issue new 10-year bonds for some much needed expansion projects. The company currently has 7.5% coupon bonds on the market that sell for a premium, right, of $1,072.78. They're going to make semi-annual payments and they're going to mature in 10 years. What coupon rate should the company set on its new bonds if it wants to sell them at par? Well, that last sentence basically told you all the information that you need to know to make this a real easy problem. What coupon rate, forget all the math, what coupon rate should the company set on its new bonds if it wants to sell them at par? Well, remember, if you want to sell your bonds at par for $1,000, then your coupon rate has to equal your yield to maturity, right? Has to equal current market interest rates. All right, now how do you find current market interest rates? I've said this a couple different times now, and hopefully it's starting to sink in. To find current market interest rates, all you have to do is solve for yield to maturity on any bond. Okay, so you use some kind of comparable old bond, you solve for yield to maturity, and voila, you're done. So this is really a one-step problem. Okay, a one-step time value money problem. But conceptually, I've put up there the comparable for the old bond and for the new bond so that you can kind of mathematically see what's going on. One step. Let's try it. First thing you're going to do is figure out what's the yield to maturity on the old bond. So N equals 10 times 2. Remember, we're dealing with semi-annual payments here. That's 20. I is what we're going to solve for. PV is going to be negative the price, which they told us, of $1,072.78. The payment we have to figure out, they told us that it's a 7.5% coupon rate bond, so we're going to take 7.5%, multiply it by par, and divide by 2, and we're going to get $37.50. The future value is obviously par 1,000. You solve for I, okay, and in this case, you get 3.25%. Now, make sure you multiply by 2 to get the annual yield to maturity of 6.5%. Okay. Well, now that we know 6.5%, we know that the current market interest rates are 6.5%, and if we're going to issue a new bond, we want to issue that new bond with a coupon rate of 6.5%. So to prove that, look at the new bond at issue. And I would tell you, you can mathematically prove this by putting in 20 for N, and then put your I at 6.5%, and then skip the PV, go to C, and put in use 6.5% times par divided by 2, okay, and put in your coupon payment, and then for your future value put in $1,000, and then solve for price. If you get $1,000, then your price equals par, and it will, right? So that new bonded issue information is really just a mathematical proof to set up that to prove to you that if you can find the if you can find current market interest rates based off of the yield to maturity on an old bond, then that can be the coupon rate for your new bond at issue, and price will equal to par. Okay? And remember that, because that's a really important conceptual problem for some of these math problems. Okay, now let's take a look at another problem. It's got a slight twist to it. It's a little bit like the second problem we did where you found the coupon yield, the yield to maturity, and the coupon rate. Sorry, the current yield, the yield to maturity, and the coupon rate. But in this case, you don't have to find the coupon rate, but you do have to find something else. Here we go. Kaiser Materials has a 9% coupon bond. Okay, so why do you not have to figure out the coupon rate? Because I just told you it's 9%. On the market with 17 years to maturity. The bond makes semi-annual payments and currently sells for 96% of par. So 96% of par obviously means that we're dealing with a discount bond, right? What is the current yield? There's one. The yield to maturity, 2. And what's the other one? Something different here. The effective annual yield. All right, so let's take a look at how we do this problem. Let's do them in order, right? First thing is the current yield. So to get the current yield, you just do the annual coupon divided by price. So to find that annual coupon, you take the coupon rate of 9%, multiply it by par, right? And you're going to get $90. And then you're going to do that over the price, which is going to be 96% of par, or 960 bucks, right? So 90 bucks over 960 bucks gives you 9.375%. Bingo. Number two, let's get the yield to maturity. And remember, it's got to be annual. So, but we're dealing with a semi-annual bond. So N is going to be 17 years times 2 for 34 semi-annual payments. Skip I. The price, which we just saw for before, is going to, or we just figured out before, is going to be $960. Make that negative. The payment is going to be the coupon rate times par divided by 2. So that's going to be 45 bucks. Future value is always $1,000. Solve for I, you get this 4.7391%, which is your semi-annual yield to maturity. Multiply that by 2. Bingo. You got 9.4782%. Okay? Now, in the next step, it says the effective annual yield. How do we go about that? Well, remember, you have your, your I conversion button on your calculator, which is second and then the number 2. And you need to know what your nominal rate is, or APR, your compounding per year, and then the effective. You got to know 2 of the 3 and solve for the third. Well, to make this a lot easier, remember that nominal, or your APR, is going to be your annual yield to maturity. So you take the number you got from step 2, you plug that in for nominal and hit enter. Then you're going to hit the down arrow twice, go to compounding per year. It's a semi-annual bond, so you'll change that to 2, hit enter, hit your arrow up, and you're going to hit compute for EFF, and that'll give you your effective annual rate of 9.7028%. Right? Now, once again, you could also use that reasoning from the first problem that we did to check. We know we've got a discount rate, so the yield to maturity should be higher than the current yield. That should be higher than the coupon rate. So what's our yield to maturity? It's about 9.5%. What's our current yield? It's around 9.4%. And what's our coupon rate? It's 9%. So they all go in the right order. Bingo. Okay, so that's a wonderful way to check and conceptually make sure you understand what's going on. Now, for a change of pace, let's take a look at a Fisher equation problem. Okay, so this is one of the few problems where we're not really solving for the value of a bond or one of those crazy rates. We're actually dealing with the concept really here of inflation. So if Treasury bills are currently paying 4.8%, okay, what is that 4.8%? That 4.8% is going to be big R. Now, what is big R? Big R is your APR, your nominal rate, that yield to maturity, whatever you want to call it. It's your stated interest rate, okay? And if the inflation rate is 1.9%, then what's your approximate real rate of interest? Well, remember, inflation is based off of like the consumer price index and has to do with the changes in your purchasing power. So your real rate of interest tells you how much your purchasing power has changed, okay? So there's 2 ways of doing this. There's the exact way, and which is known as the Fisher equation, and then there's kind of like an approximate rate, which is your rule of thumb. The approximate rate is super easy. All you have to do in this case is take big R and subtract H. So if we know big R is 4.8%, subtract H for inflation of 1.9%, your answer should be close to 2.9%. Okay, but that's not going to give you the exact answer on the test, so I would do that second actually on the test, maybe as a check. The exact way is 1 plus big R equals 1 plus little r times 1 plus H. Notice there is no addition sign between those parentheses there for 1 plus R, and then there's no addition sign there. It's a product or a multiplication times 1 plus H. Okay, so you can rearrange this, and you get the equation below of little r is going to equal 1 plus big R over 1 plus H, all of that minus 1. And so let's do that. 1.048 for 1 plus 4.8% over 1.019 for 1 plus 1.9%. You do that division, you subtract 1, and you'll get 2.8459%. And that's the exact answer, right? So your real rate of interest, or your change in purchasing power, is going to be 2.8459%. So although you might have made 4.8% off of this Treasury bill, it didn't really change your purchasing power by as much as you think. Okay, and just conceptually for thinking about that, if you, for example, let's say you made 2%, okay, on an investment, and the price of milk went up by 3%, then did you actually make money? Well, not if you're buying milk. If you're buying milk, you actually lost a little bit of money because of inflation, right? Okay. Now let's take a look at Deltona Motors problem here, and this is another zero coupon bond. Okay, problem. So Deltona Motors just issued 425,000 zero coupon bonds. What do they pay? What's from an interest perspective? Nothing, right? They're zero coupon bonds. These bonds are going to mature in 15 years, have a par value of $1,000. I didn't even have to tell you that, right? And have a yield to maturity of 8.45%. So what is the approximate total amount of money that the company raised from issuing these bonds? So it's kind of like that zero coupon bond problem before, except in the reverse order. Here we're trying to figure out how much money was raised instead of what that last payment would be. Remember, a good trick with these zero coupon bonds is always, hey, I got to figure out what the price is, right? Because they're being sold at a discount. So in this case, we're going to assume semi-annual compounding. Once again, that doesn't make a huge difference with zero coupon bonds, but just roll with it. Number one, okay, first find N. 15 years, you multiply that by 2, you got 30 semi-annual periods, okay? I is your yield to maturity. They told you it's 8.45%. Now, since you're dealing with a semi-annual bond, you're going to divide, not multiply, but divide by 2, right? Get 4.225%, put that in your calculator. Skip over price, your payment is obviously 0. Your future value, obviously 1,000, right? So you compute price, and you're going to get a very deep discount here of $288.96. Okay? Now, what's the total amount you've raised? Well, all you have to do in this case is multiply however many bonds were issued times the price. You do that, you get 122.8 million or thereabout, and I'm not going to. The answer is going to be, pretty dang close to that on an exam. I'm not going to try to confuse you with the answer much, but this is a super easy problem, right? Everybody see that? Well, there's one of your zero coupon bond problems, and hopefully that will be one of the easier ones for you on the exam. Now let's take a look at problem number 38. 38. This might be a little bit more difficult than the previous problem, conceptually at least. You own 2 bonds. Both are going to pay you annual interest. They both have 8% annual coupon payments, right? So their coupon rate is 8%. They both have $1,000 face values, obviously. Didn't have to say that. And currently have 8% yields to maturity. Okay? So they're both priced at par, right? Because their yield to maturity is equal their coupon rate. Okay? At least as of right this second. Bond A has 10 years to maturity and Bond B has 3 years to maturity. Okay? So the only difference between these two bonds is their end value. If the market rates change, so I put falls here, but it could be increases. It's a good hint for the exam. Unexpectedly, so interest rates fall unexpectedly to 7%. What happens to these bonds, right? Which one's going to be more volatile to change in interest rates from a price perspective? And what is going to be that change? Okay, so if the market rate of interest falls unexpectedly to 7%, bond blank will be the most volatile with a price increase of blank percent. And those blanks will obviously be your answer choices on the exam. So we know for a fact what their old prices were, right? Because that's just what we started with. We started with $1,000 for both of them. Now, what are going to be their new prices? Well, the first thing that we're going to want to do here in steps 2 and 3 is figure out what their new prices are. So, if you look at steps 2 and 3, the buttons are exactly the same except for N. With bond A, N is going to be 10. With bond B, N is going to be 3. They're both going to have 7% interest rates. And you're saying, why 7%? Remember, the interest rates have changed. It went from 8% to 7%. So 7% is what we're going to use for yield to maturity because that's what current market interest rates are. Payment is going to be based off of that 8% coupon rate. So you're looking at annual payments of $80. Future value is going to be par. You solve for price. And what you notice is a bigger change with bond A than bond B, right? Bond A shot up to 1,070, whereas bond B only went up to 1,026. Okay, So obviously bond A is more volatile, and what you're also going to notice here is then that you need to figure out what that percentage change is. And you can do, there's anytime you have to do any percentage change for anything, not even in this class, just in life in general, you can do new minus old over old, right? So to find the price change, we're going to take the new price minus the old price over the old price. So for example, with bond A, we'll do that 1,070 minus 1,000 over 1,000, you get 7%. With bond B, we're going to do that 1,026 minus 1,000 over 1,000, you get 2.6%. Okay, so your answers, if you go back and look at the blank, is that bond A will be the most volatile with a price increase of 7.02%. Okay, now, what else could I do? Remember, I told you I could change that interest rates to where it increases. What's the bigger point here? The bigger point is, why was bond A more volatile? Well, remember, longer bonds have just have more inherent risk in them. A lot can change, okay, over that longer period of time. So they're going to be more volatile either way, and that's something that you should really understand. Whether the interest rates go up or they go down, bond A is going to be the most volatile. Okay, so keep that in mind for the exam. All right, let's look at the hot dog shack problem. Okay, Hot Dog Shack wants to raise $2.3 million by selling some coupon bonds at par. So if it wants to sell them at par, that means that price of the bond is going to equal par, which only happens if the yield to maturity equals the coupon rate. Okay, now we can find that yield to maturity based off any old comparable bond. So comparable bonds in the market have 7.5% annual coupon rate, 20 years to maturity, and are selling at 107.687% of par. What coupon rate should the Hot Dog Shack set on its new bonds? Okay, very easy problem. All we got to do is solve for I, and we're done, right? So on the solve for I on these older comparable bonds. N is going to be 20, right? They told us that, 20 years. Price is going to be $1,076.87. Got to make that negative. We got that from the percentage of par. Payment is going to be that coupon rate of 7.5 times par, so that's $75. Future value is 1,000. You solve for I, and you're actually going to get the annual rate here, right? Because we're using an annual bond. All right, so that 6.7864% is your answer. All right, if you set that is your coupon rate on your new bonds, then they will be selling at par. All right. In other words, this problem works almost the exact same way as problem number 34. And so if you're a little bit confused, go back and listen to what we did in number 34, and I'm sure that'll clear it up. All right. Here's our last problem for the test guide. Number 40. A bond has a yield to maturity of 10.41%, a 6.5% annual coupon, a $1,000 face value, and a maturity date 14 years from today. What's its current yield? All right. So this is kind of a two-stepper. One of the reasons why is because they didn't give us the price. So you could kind of do step 2 first if you wanted to, say it that way. I just try to show it here logically to you, but you're definitely going to have to, logistically do step 2 first. To get the price, we know N is going to equal to 14, and somebody might say, how do I know whether or not this is a semi-annual or annual bond? Well, on the exam, I'll tell you exactly. But here, the fact that they tell you that there's an annual coupon and they don't tell you that there's semi-annual compounding going on, it's safe to assume annual compounding. Okay? But I'll clarify that on the test for you. So N equals 14. I is going to be 10.41% because that's the yield to maturity. The payment is going to be 6.5%, which is the coupon rate times par of 1,000, so that's $65 for payment. Future value is always 1,000. Solve for price, you're going to get $718.29. Now, to get the current yield, remember that that's just the annual coupon over price. So you plug in your answer from 2 into the denominator. You put that $65 annual coupon in the numerator. You solve, and you're going to get 9.0493%. So that's a pretty easy problem as well. All right, so that hopefully gives you a better understanding of bonds and definitely a better understanding of those 10 math problems that you should expect to see on exam 3. This concludes lecture 3.3.